I think this is the very best time to be doing neuroscience research, partly because of the convergence of tools, the growth of the field. It's very mature. We can do things we could only dream of doing. I think what's happened now is there's been an integration of different types of monitoring methods, calcium imaging being a good example, multi-electrode array recording being another, and genetic tools for manipulating neural activity, either slower acting forms of neural silencing through dreads or tetanus toxin, and of course very rapid modulation of neural activity with opsins of various kinds. That's a complete, in total, that's a complete game changer for doing something that I think was impractical until those techniques could be integrated, which is getting to a systematic causal linkage between neural circuit properties and activity and very important aspects of brain function. I mean, things like perceptual processing, learning, memory, fine motor control, sensory motor integration. And I think that's where I see it going. I mean, I think it's already there, frankly. I mean, I think we're right in the midst of it. I feel really lucky to have been developing my career over a time when those tools became more and more available and allowed us to start to interrogate in real time brain function in the context of natural behaviors. My grandfather, who was a mechanical engineer, he worked on locomotive air brakes, and he was a very, very good engineer. He said, what are we ever going to learn by studying songbirds? How is that ever going to be relevant to human health? And, if he were alive today, I'd say, well, tremendously. We've been able to use the songbird system and the incredible stereotype sequential vocal behavior in those animals to probe the behavioral consequences of expressing disease-related genes in the basal ganglia. So I think that that aspect of neuroscience also has me very excited.